I don't know if presence comes through because he uses a bridge to Slack. So I don't know if
Oh, that's right.
he's on Matrix, I think.
Well, if I look at, or let me find the right page here. Tycho, I think you're going to be it. I'm going to tag you for this. I'm trying to forward you
Sure.
this. So basically, this was OCI V2 Part 2.
Yes. And I think my recollection is that we sort of left off with trailing discussions after mountable file system format. Is that right? So I think the next major item is bill of materials.
Yeah,
If my
except that I don't see Nisha here as well.
right.
Actually, not sure what time zone Nisha's on.
Yeah. So I guess I in principle I can express the idea of bill of materials, which is you shouldn't have to extract the file system content uh, in order to figure out what's in there. So what this means is the metadata should be stored and compressed separately from the actual file content, meaning, you might have a file that is at this particular path, has these extended attributes, has this hash, blah, 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 but the actual content is stored somewhere else. And in fact, this is the way SquashFS does it. It compresses metadata separately from file contents, and that's one of the ways that SquashFS achieves its speed. So at least in my mind, this sort of just comes out of, if we do format design correctly, this should come for free. I don't know if Nisha has something in mind besides, compress the metadata separately so you can go through all of it. Uh, there's some discussion here about, tar archives are flat files. You can't seek in them. Again, I think all that kind of stuff comes for free from just compressing the metadata separately, or not even compressing it, but whatever, storing the metadata separately from inline file data. And does that sound reasonable to everyone?
Yeah, I think it's just challenging not having, unfortunately, having Nisha Alexa here to talk about it. Because the thing about this one, because there's been a couple of different SBOM efforts that are going on, and I'm kind of learning just listening to others talking about it. And it's not just the contents, because to some extent the vulnerability scanners can figure that out. They can. It's not efficient by any means. So having an SBOM that says here's what's in it is certainly a better efficiency. And if you could sign it and trust the signature, then you could not have to do a deep scan every time. The thing that I've been learning more around some of these is the challenge is also what compiler was used, which you can't necessarily tell by looking at the result. Where was it built? Was it built in an environment that is more secure than others? Who was it built by? Was it built by a build system that was not not vulnerable, or was not later found out to be hacked in some way? So the things about the SBOMs that I've kind of been seeing more confidence in, if you will, is the ones that are doing like during a build time, and they have a better visibility about what's being done, and anything they consume also would have an SBOM associated with it, which means it goes back to chipping rocks. But the point is that you can at a certain point take a reference saying, okay, here's the content I'm consuming in an image format. It's the from statement. And if there's no SBOM for it, then you have to kind of accept that's a starting point. But then here is the things that I've done to generate this image. Here is the SDK image maybe that I used. Here's the compiler that I used. And in something like Go, here is the final result of what was built and how it was built. That stuff you can't necessarily look back on by the resulting image. It's really important during the build. So if you can generate that SBOM at that point, then, there's some examples in here that we were doing that show, hey, we can just store the SBOM as another, whatever format it is, it's some kind of text file in an artifact that's alongside the whatever artifact or facts that it's attesting to, and the whole thing could be stored as an index. So I think the SBOM format is more about how do you generate the SBOM as the source.
Yeah, I guess that's what I was wondering, because at least in principle, it seems like you could actually do this with OCI v1. You have a manifest attribute that you would, write whatever this magic format is, but, how do you generate it in a consistent way? Because some things use automake, some things use go build, some things use blah, 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 SCOMs or whatever, WAF, right. Choose your favorite build system. And so, what does that format look like?
Well,
and I guess
sorry, I'm late.
Alexa, welcome.
No, fire away. Yeah, go ahead.
Yeah, I was gonna say, yeah. So generating it is one thing, but the other thing is, okay. So if we solve the generation problem, you can either say, oh, we solved it by, everyone decides to start packaging for distributions, and then we just get the distribution build list. That's a pie in the sky idea. Or you can go about it by having other ways of generating it as an image building tool. But the other thing is the reason why we need the consideration for this in OCI v2. And I don't know if this has been mentioned yet, but it's the problem right now is that if you had an SBOM, there's no way of verifying it. So like if you had an SBOM that was generated and you run the image, there's no way you can actually say, well, there is a way you could, moving to exaggerate that. It would be difficult or more annoying to verify the SBOM actually matches the image, like the data in the image. So the consideration here is not just, could you technically have done it? It's also a matter of how verifiable would it be? Because in theory, if we have a format where you can easily match parts of the file system tree based on hashes or whatever with the SBOM, you can then very quickly say, given this SBOM, I can verify that actually these files in the image actually do match what the SBOM says. So that was one of the things, one of the reasons why I wanted to make sure we mentioned SBOMs.
But the SBOM says it was built with this version of GCC and these optimization flags, right? So, you want to take the binary and go backwards from that somehow, or I don't understand. Or is the idea that GCC would admit? Sorry.
Okay, maybe not verify all of it. I'm saying that what you could do is, the example that I'm thinking of is distro packages, for instance. So if you were to say, I have this Ubuntu image, and the Ubuntu image would say, these are the list of packages. Now, obviously, for non-distro packages, this would be different. But the idea would be you would have, this is the Ubuntu image, and the Ubuntu image I have, bash, and this is the version of bash, and then this is the hash of the files that bash has, that the bash package has, and so on and so on and so on for every single package in the system. You could then take an image that has this SBOM, and you could say, are all the packages accounted for? So the packages in the SBOM, do they actually match the image? Is there anything in the image that isn't in the SBOM? And if there isn't, you could create an administrative policy saying you can't run anything that isn't in the SBOM or something. That would be an example of something that you could do. And then there would be some sort of signatures or something which would say that this actually did come from whatever vendor it is, Ubuntu.
So it's really just a hash. Is that, you're not expecting anything more than a hash of the binaries and libraries and whatever?
Well, that's what I would like to see, personally. That would then be signed by a vendor. That's my idea of it. I don't know, is Nisha on the call?
No, we were just talking as
okay.
You and Nisha weren't here to represent, so we were trying to cover as best we could.
Yeah. It's my understanding that based on what you said last time, what she's been saying, she's wants to have something that's as minimal as possible, because obviously there's different SBOM formats that completely disagree with each other in terms of how they're constructed and all the rest of it. I think that for me, that's what I would like to see. I know that people would also like to see other information about how how this software was built. And I imagine if it's software that was built separately from, I mean, distribution packages are easier because you can usually, for basic A distribution, you can fetch the sources and rebuild them reproducibly. So all this information wouldn't make sense in the SBOM because it's information that is public anyway. Like you can get it through other means. But for like packages that were built by a vendor that aren't packaged, sorry, for software that was built by a vendor that isn't packaged, you would want to include some information like that. But I think there is like, you can always add more metadata that is like extraneous stuff. And I mean, if these SBOM entries are signed, then if the vendor signs it, then that's sort of, I mean, that's enough information, I think. I realized I didn't answer your question, sorry.
I think there's some low-hanging fruit things that people are thinking about, and I guess I'm somewhat hopeful that this secure supply chain working group that's been working, and it's across Google, AWS, Azure, GitHub, and some others, the 3T SBOM group, including K for SPDX, and there's just a bunch of people I've been popping in and out when I'm available. I'm kind of hopeful that they're going to come up with something that I think will be the superset, if you will, but it's a superset in a reliable way, because there's a number of us large software manufacturers that are getting put in a spot where we have to have something. And it goes from container images to software on, like everything is becoming software, but it's like software on pacemakers or in cars. So the idea that you can put software into a car that could, you know, pretty soon drive any direction at once with lots of weight and things, or trucks, is becoming pretty scary. When you add to that the amount of open source that's being used in these, that whole thing is just raising the bar on it. So I'm hopeful that they're gonna land a pretty good spec that will be able to support with the artifact stuff. And in fact, there was a link in there that had a mock of it. Some of the stuff that you're kind of drilling into, Alexa, is almost like the verifiable builds, so the reproducible builds. So I wonder if there's some extra stuff that can be, because we definitely have some challenges there of the way an image is built and then even decompressed, that it's really hard to, you know, some of the digest and stuff can get recalculated in a way. Yeah, so I think that's unique stuff to us, is kind of what I'm getting at.
Yeah, but I guess my point is that if we have a bill of materials for an image, I would ideally like for it to be the case that this bill of materials is not just like metadata that, I mean, it's useful, but it's not like, it's just metadata that's attached to the image that isn't verifiable with the image. I think this is something we'd have to discuss with, it would be ideal if someone else solved this problem for us and we just use whatever they come up with. So I think, yeah, I mean, I'm not involved with the SBOM stuff, like with the specs that are mentioned in the document, ones you mentioned. Though I think Vincent was talking about it before, and obviously
he was invited. He was a part of some of the initial one, yeah.
Yeah.
So I'm trying to get those guys to present to us their status. They're still in a bit of a churn state, so you know, I think they're trying to get a schema and some focus on it. So maybe once they get a little further along, we can get them to come and present.
Yeah. I mean, worst case, if the format they come up with is at least somewhat extensible, we can always add the couple of things that we would want. Like the one thing that I would like is that we can say, given an image that has a bill of materials attached to it, then you can actually say, does this bill of materials actually match the image that we're going to run? And this is less about reproducibility, more about like verifiability. Like it's yeah, all these things are signed, but if you have a bill of material, well, it depends how signatures would work with bill of materials. That's another topic. But if you were to say, okay, I got these packages from this vendor, and then I put on top of this base system, I put these things, and then I gave it to someone else, and then that person added these things, and that's the code I'm going to run. Ideally, it would be possible for me to verify that is what happened. Like, not that it is what happened historically speaking, but like the end result matches what the SBOM says. That would, I think, would be ideal. Whether or not something we can actually achieve is a sort of second question. But yeah, I think having having a person in the room or having a discussion with the SPOM people once they have a more solidified schema idea would definitely be good, so that we can make sure that either it matches the sort of things we would like to have, or it will be possible for us to have to add the things we'd like to have without clashing with.
It is extensive. It is expensive.
Yeah.
So think about it as a from statement has an SBOM, and then you add something to it. There's another SBOM, and the superset SBOM links to the other one. They've modeled a little bit after car manufacturers. Like you have a car that's assembled and it's got a Takata airbag in it, like as a lot of cars apparently do. And the Takata airbag has components in it and how it was built. So there's like this nested approach they're going to. And then the idea of signing to say that this was signed by this entity and moved on. So it sounds like the components are there, which is, or they're evolving. Cool.
That's good. I mean, I like hearing that other people are going to solve our problems for us. That makes me very happy.
They're solving parts of them, and then we have to figure out how to represent it in the registry. That's why that's been my participation, is make sure we have some registry support, because all the stuff they're thinking about winds up as a container image to be deployed in many cases. So, yeah. All right, so now that you're here, do you want to represent this? Like that was the bill of materials. You want to move on to the lazy fetch support? Tycho was trying to fill in, but he was like, where's Alexa?
Yeah, sorry about that. I was having, I should stop using Linux, I think. I mean, such a pain in the ass to get, to join calls and things. Okay. Yeah, all right, let's just go ahead. So yeah,
Spoiler alert,
bill of
it's not better on
materials.
Mac. It's just not better.
What was
Continue.
that?
Go ahead. I was giving Alexa shit. Continue on. Thank you.
Yeah. All right. Okay. Anyway, so lazy fetch support. So I think Wei is on the call, or is I guess Akihiro is also on the call. I guess I should ask, who would like to speak about lazy fetch support? Hello?
Going once?
Hello? Can you hear me?
Yes. Hey, Wei.
Yeah. So basically, I think the lazy patch is we want to make the distribution faster. So we know there are only few files of the image is using to run a container, right? So but we have to wait for pulling the entire image. So it will take a long time, especially for the huge image, for the machine learning. It maybe take 5 gigabytes. So for the distribution reason, we make an index for the file for the original image, so we can patch the file. We can patch the single file from the original image from the registry. So this is the so it is the main goal, but we have some issue related to the authentication. We know we need to refresh the token when we get the file. So right now I think most solution for the lazy patch is using the admin account to get the file. So I think it is need to improve the existing authentication. So yeah.
So is it the one thing I just want to clarify with lazy fetch support is that, so is this right? So obviously with tar archives, this is difficult. You have to replace. I remember reading this when you first published it. It was effectively you replaced it with star.gz, right? So like you fetched it with the format that you can download bits of it without having to download the entire thing. Is that right?
Yes. Yes.
Yeah. And so I guess the question is that for lazy fetch support, from the image spec side, because obviously there are two parts. Is like what would need to be done. Is there anything that would need to be done for distribution, which I think you're mentioning? But for the image spec side in particular, is it just a matter of that the data has to be like accessible with like greater granularity? Like for instance, the example, like the I guess the example version the prototype I gave last year, which was like you just expand all the files and then store them as individual blobs. Is that actually enough for lazy fetch? Like something like that would be enough? Where rather than having these giant blobs, you have small blobs for each file that you can then whatever runtime tool you use could just fetch the bits that are needed. Would that be sufficient, or is there something more that would be needed?
Yeah, I think we need to define the format for the metadata for each file in the image. So
right.
So the metadata may be the few bytes. So when we download the image, so we need to only download the metadata. We don't need to download the whole files, whole image. So I think the key point is we need to define the metadata format, and we need to improve the when we when we download the file on demand, and we need to know how to get the fresh token. So
sorry, the what token?
The authentic.
Fresh token.
Yes.
Okay.
Yes.
All right. Well, I guess Steve, that's on your side of the court, right?
Yeah.
I'm sorry. Did you just toss the ball to me?
Yeah, I was saying that. So from the image spec side, the main thing is that needs to have some sort of metadata that's you can download it without having to download the entire file, which I think is something which we would need for the other requirements anyway. But for the distribution side, apparently authentication needs to be made easier, or needs to be made easier.
That's what That's what I heard Wade talk about. It's an interesting problem is that when you have a long-lived operation, that the refresh token scenario, which none of this stuff, as far as I understand, is called out in the spec very well. Like authentication is kind of just, it's not just ignored. It's definitely problematic across cloud providers. So that's it. That is an interesting problem. Like the stuff we're doing with teleport's a little bit different. So it's, but it's not something that you can put in a common spec. So the thing that we found, part of it is you got to figure out which you're optimizing for. So when you're doing internet protocols where the networks are not reliable and they're kind of far away, there's a different optimization where the compression really makes sense. Inside of a data center, we've found that doing lots of individual file pulls actually can be problematic as well, because there's so much overhead with the back and forth. So there's a set of interesting problems in how to do this in a generic way.
Well, I think a lot of that can be solved through finding out some way to do chunking. Like I think that's kind of where the magic is, like finding that middle ground. But to the authentication thing, I think this problem is really something that Kubernetes has today. Like it's not unique to like lazy fetching. I mean, when you define like some pod spec and that it needs to run, like you don't know when it's going to get rescheduled and repulled, and like this idea of just having tokens that you could refresh and use for your entire operation, all the way down to the container runtime level or the distribution client level, I think is just a concept that's kind of missing from the registry today. Like we added some rudimentary notion of tokens, like refresh tokens in like the Docker distribution, but it's not really well used, and it's, you know, it's certainly not by like Kubernetes and stuff. But yeah, I think at some point we need to address this head on in the distribution spec. Even if we don't come out with like our own like specification for it, we need at least have like a better recipe there or something. Like, I know back in the day we talked about like macaroons, or like back when that was popular as some notion of doing that.
For registry authentication, we can just use Kubernetes secret with Docker config JSON type. So we have a strategy that's snapshot, and we already have support for syncing Kubernetes secret to our snapshot. So Kohei Tokunaga, are you on this Zoom, right?
Oh, yeah. Hi, I'm calling from strategy snapshot, and yeah, and eventually we have kind of syncing mechanism with Kubernetes API in terms of secret. So yeah, I think it is one of the good way towards authentication on Lazyboard.
Yeah, I think the only problem we have with like, as I say, secrets today is just they're very widely scoped, and handing them all the way down to the container runtime is almost not great. Like basically it's like pushing that secret even farther down, where potentially even like applications could access it more. So like, yeah, I think it's definitely a solution, but we should, I think at least we should propose something better.
Yeah, I think so. And yeah, from study snapshot's perspective, if I can add something to the spec, I think in addition to like authentication and file level marquee or hash tree, I think we can add two more things. First one is like in current spec we have many kind of digest IDs for layers, like inflated or the compressed diff ID and possibly compressed layer digest manifest and snapshot chain ID. And yeah, when it comes to file system implementer, it is quite compressing to deal with all of these IDs. So I think yeah, maybe it is distribution spec. Maybe this should be added to distribution spec rather than image spec, but I think kind of addressability based on the root file system snapshot chain ID, it will be also needed. And second one, I think we will need is like from performance perspective, I think yeah, sometimes, well, yeah, especially in study snapshot, of course, on-demand file fetching is quite costly in terms of like performance, because every time we access to file, we need to download the file from the registry, and it's very costly. So in study snapshot, we have kind of prioritizing mechanism of like, or dealing with like a file access order, like because container image is built by purpose, and so the workload is defined in the build. So we can apply kind of workload-based optimization for images. So and in this case, we need some kind of marking mechanism for files in an image. Like this file is very important when starting up, so we need to prefetch these files, something like that. So we need to, I think we will need kind of like such kind of marking or annotating mechanism for in file level in a new spec, I think.
Yeah.
And this starts getting into extensibility, which is the next topic.
I
wanted to
so,
say that. Yeah, is that in theory? I mean, if we just, I mean, that the extensibility part, not getting to compression yet, but the extensibility part is something which, in theory, would be handled by if we just use descriptors. Excuse me, if we use descriptors to point to the blobs, and the descriptors are attached to the metadata of the file, you could just add annotations that are like, you know, whatever, important file or whatever, and then that would be, or priority or whatever you want to call it, and then that would be usable without having to put it in the spec necessarily. Just having these annotations would I think would at least solve that part of it. For compression, I mean, I don't want to speak for the distribution maintainers, but one thing I actually want to discuss, and maybe we should have another call about this separately, is if we are going to split into having lots of small blobs, having compression in the image spec actually does cause us some issues, not just with reproducibility, but it also causes issues with if we want to use chunking, because if you can either chunk before you compress, or you compress and then you chunk, and it's sort of like the it's sort of, well, it's not like in compression and encryption, but it's basically both ways are bad, because if you compress then you chunk, then you lose the benefits of content-defined chunking, because the content is, I mean, it's compressed data. It doesn't have the same structure as the source data does, at least in terms of chunks. But if you compress the chunks, you lose the compression benefits, because I mean, you're compressing like a 1K block rather than a 40 meg file, for instance. So one of the things that we should discuss at some point is if we're going to have, if we should have a discussion about whether or not compression should be something that is more put on the distribution side for OCI v2 rather than the image spec. And also, when it comes to pulling files, if we have this situation, and this gets actually back to what Steve was saying with small files being, with lots of downloads being prohibitive for inside data centers. And I mean, you know, I mean, I would say it's also prohibitive if you live in a country which has like questionable internet, like Australia, that having a lot of round trips for small files can get quite painful.
Yes.
Ideally, I would say that if there was a way to do batching of downloads, for instance, something like that, that would be quite neat. I believe the distribution doesn't do that, right?
Yeah. But yeah,
from our experience, like, and we'll have more hopefully examples soon, but what we've seen is there's different performance metrics you want when you're doing an internet connection, which is a lot of our developer laptops, especially now that we're all working from home, compared to an inside of a data center scenario. So if you take, you know, many of the larger image, which is unfortunately the reality, is many of the images are relatively large. When you're internet connected, the speed, you know, the download speed is, the compression really helps, and you have fairly robust computer where you can, the memory and the processor to decompress is fairly optimized. So that works really well. When you're inside a data center, you're, you know, in every data center, you know, at this point, you're sharing some kind of virtualization. So the memory and compute is the hard part, and the network is relatively fast. So it's, I don't know if there's any one size fits all. And for us, what we found, this is more of a registry side, a distribution spec side, if you will, optimization that's done, and the server kind of does the thing that you need, and the client says, well, here's what I'd like to have. And the registry can then serve that style of request.
Yeah, so I think actually we're in agreement then in that, yeah, if it's something which the registry is not, it's not always compressed, the registry could choose to compress it, and perhaps even for like, as an extreme optimization, you could then store both the compressed and uncompressed versions, so you don't have to compress on the fly, for instance, or however you want to do the optimization. Having it on the registry side makes it so that you can handle both use cases, but also sort of would also on the image spec side would help us eliminate some of these limitations that having compression in the spec causes, both in terms of reproducibility, but also in terms of just like being efficient with chunking and all the rest of it. But sorry, I cut someone off.
Yeah, this is tough from Ant Group. Is it possible to have different compression algorithm options? For example, one chunk for small files that are not chunked, or that are not compressed, but for large files we still choose to compress.
Yeah, that's what I was about to say. Like some chunking
chooses like how big, it's kind of getting to how big you want the end chunk to be. So optimistic compression based on desired chunk size.
Yeah, so compression can be a per chunk option instead of being set on the image level.
Yeah, the problem with compressing individual chunks is that it's you lose you lose one of the main benefits of compression, which is that the more data you have with more structure, the smaller the output is, right? Like if compressing 10 files that have similar structure individually will give you a bit more data at the end than if you were to combine them all and then compress them all in one go.
Yeah,
at least in theory.
If you are looking at the file level, I think we inside the chunk we can have compression, and across chunk we can have across chunk hash to dedupe the data. This can work with the deduplication. So we do not can have cross many different chunks then share the same data.
Yeah.
Excuse me. So aside from this compression topic, can we conclude that lazy fetch support is very important to our image spec?
I think and I've been trying to give pause because I keep on seeing Derek unmute his mic. So let me just hand off to Derek for a second.
Oh, I was just going to make a comment about the difference between batching and chunking. I was going to comment that kind of StarGZ is kind of like a batch chunking approach today, in that everything is kind of already batched together. So like you could think of it as kind of a similar way, where if you pick a chunk size and we had a way to batch everything together, you could use that for the prioritization. You pull down the first chunk, which contains all of the priority files that you need. And at that point, it's kind of like you can leave it up to the builder to make the decision of if certain files are priority and stuff like that.
Yeah, and I think in continuous use cases, I think predicting what files will be important is, I think, quite kind of straightforward, because when we make container images, we specify like entry point or user environment variables and so on. Workloads are defined during builds. So I think predicting priority is not so hard when it comes to container use cases.
Yeah, that's true. With prefetching technology, we can at least improve the application speed up. Startup time.
So the StarGZ substrate already has a feature for creating a profile or frequently using the files. So Kohei, can you give us some explanation?
Yeah, as I mentioned, we have a image converter from legacy images to StarGZ files, and in the converter, we actually run the image in a sandbox environment and profile all file accesses, and then we regard all accessed files in the sandbox environment also will be accessed in a production environment or somewhere runtime. So so far it works well. And I think when it comes to wide adoption of the image spec, I think prefetching will be beneficial for like an untrusted kind of internet, untrusted or like an unstable network condition, because batching will be efficient, especially for like such kind of unstable internet environment. So I think for widening the adoption of new spec, I think prefetching or batching mechanism should be, I think, included.
I think, yeah, I was gonna say, yeah, I think to answer the original question, which was, is lazy fetch something that is important? I think for OCI, for the image spec. I think that making it so that that it's something which can be achieved. So making the formats like amenable or like helpful to lazy fetch would definitely, I think, important. Regarding and then obviously I think distribution agrees that many of the problems that lazy fetch has are actually problems that exist anyway, so fixing them is probably a good idea, regardless. So I think we're all on the same page that this is something that maybe not is something that would be like the default configuration or something, but it's definitely something that should be possible to have. And I mean, tools already exist for that, but making it easier for these tools to operate would be good.
I think Bo made a conversation. Is it important? I think we all agree it's important. The challenge is how to achieve it. And I think just from our perspective, it's not something you can do just in the image spec on the spec of the specific artifact type. Because there's no one scenario you want to optimize one way or another. It's definitely a handoff between both the artifact type and the way a registry can serve multiple types.
Yeah, I agree.
Cool. Next.
Okay, I think we should probably move on, unless anyone else wanted to add anything in particular. Okay, we'll take that as a no. All right, so extensibility, I think I already mentioned on this. Basically, I think that if we have a format that is, if we use descriptors for pointing to things, I think this is already covered, basically, because the problem with TarGZ was that you could extend it in theory, but it would be absolutely painful to do, and no one would support the extension. But because we have annotations and descriptors, in principle, this is already a solved problem, I think. So I think we can just move on.
The one comment I made, especially because I see Vincent there, is for me, the interesting thing is you've been much more focused on the image spec, the runnable image that I kind of refer to. And we talk about OCI V2, we kind of think, I was thinking about them together. As you think about extensibility, and the reason I'm pulling Vincent is, like, originally when I think about extensibility, I thought we were talking about the work that Vincent had been at least brainstorming on. I'm challenging him to actually come up with something. But he's been more focused on the distribution side. It'd be interesting to see how an image spec or an artifact type, there's this handoff back and forth. Says, hey, I have this extensibility model. I'd like to be able to do this. Hey, registry, do you also have this extensibility model? Do we match? Can we talk in this extensibility thing that we want? And I'm sure some of the extensibilities have nothing to do with a back and forth, but it'd be interesting, whoever's, like, I'm just looking at
the best I can say on this one is effectively, if I read this section correct, is that the way that we're abusing the manifest and manifest list for things like artifacts and ORAS and otherwise, is that certain things should have been a little bit more, like layers should have had a different name, and some of these fields that just kind of like foretell about other pieces effectively, so that registries could garbage collect easier, is what this is alluding to, so that we can kind of like point to the nature of the type without having to indicate it's only an image or it's only a tar layer, and there's other objects pushed that need to be garbage collected. Am I wrong in that, or what was the goal of this piece?
Let me explain it a little bit. The goal of the extensibility is to define the image format so that we can have some kind of optional features. For example, how the image are signed, or what kind of hash algorithm is used, and what kind of compression algorithm is used, and on what kind of level, how do we chunk. And we have, and I'm raising this because we have different implementation proposals, and we are discussing all these different features, and some of them I imagine will be mandatory but some of them will be optional, and the image format we define should be able to tell what features are optional in and what are not, and let people decide
Do we not
when they
have
build
that
it.
now with like the digest or in the MIME type media types? Do we not have some of those features already?
Yes, some of the features are already optional in, but some are not. So and just saying the format should have a formal way to define it.
Mm-hmm. So I'm also trying to understand a little bit, and I put a joke in the chat session of you calling the artifacts and all that stuff abusive, but at the same token, you brought up a question of garbage collection, and I'm curious about that because as far as I understand, the approach we've done where layers are still referenced by manifests are still referenced by indexes, there is information there that allows us to figure out what needs to be garbage collected and what not. Everything from deleting to a push fails halfway, and there's there's an inconsistent state we clean up. So
some of those are already handled by the registry, and I shouldn't. I mean, I shouldn't throw around the word abusive. I mean that in the well, but a fair. But I mean, even the word exploit is more or less correct.
Wow, abuse and exploit in one call.
But I'm just saying, like some of those things are already handled as far as like being pushed in the middle of the way, and if it didn't receive the whole thing, then it keeps track of what. That's the whole thing of like which digests it even knows are referenced, and if we come up with these extensible formats that shove objects in other places, or even like one of the proposals when Alexa was first getting started on this, that would just have this long ass array of chunks. If the registry doesn't know about that, then it doesn't know to keep a ref counter on those things. So it's like a ref counter piece of it. So
you're not really commenting on what the current state is can we make sure that any new proposals maintain enough rich information so that we can do effective garbage collection? Kind of what
there's two aspects that are important there, because one is just creating too many objects in a registry that need to be basically it makes garbage collection really, really expensive if you add exponentially more objects, makes cleanup harder and stuff like that. But the other thing is we every time if we try to introduce these new types of basically new parts of the Merkle tree, I guess is the best way we try to look at it. It's kind of a shallow tree today. We have index, manifest, layer, and config, and that's kind of it. And then if you try to add something, say even star GZ, where you add a type in there, even though it's handled just fine by the pollers, it has its own security issues, because normally the clients want to be able to pull a complete object, check its digest, and then either use it or move on to the next object if it's can go down in the Merkle tree. But every time you try to if you try to make that too extensible and the registry doesn't understand it, it's hard to both from the collection perspective, and it leads to the clients have to be able to understand it. Otherwise, they try to use this thing that can't even really verify, if that makes sense. If you try to hide these things in a chunk.
I think that partially pulling blobs would be dodgy. I mean, for the purposes of verifiability, would be a bit dodgy, a little bit. But the thing I was going to say, sorry, backing up a little bit, is with regards to these. So, regards to Vincent's point, I'm not going to use the words exploit or abuse, but I will say that I think that had the image spec had the right kind of extensibility from the outset. So it is extensible. However, the way that the manifest has been used by Artifact, which is totally understandable, is that it's basically abusing the fact, use the word. It is using the fact that registries understand that and only that. What would have been ideal, I think, is if we had something like annotations, but instead of being just text, they were actually descriptors. So you could say, here are references to other data, for instance, or something like that. So it would be more, it would have been the case that it wouldn't be necessary to have a config that is linked from a manifest, even though the config isn't actually a config, and the layers aren't actually layers, for instance. But I think we're sort of past that point now. I think it's a bit too late to solve that problem, unless we were to go into like artifact C2, which would be an interesting discussion. But yeah, I think for extensibility, I think we're all agreed that we would like it to be a little more extensible, in that you wouldn't have to come back to have another long meeting each time you want to add stuff. But I think that except for having something like descriptors that are like, I guess I would call them references or something, like link tags in HTTP, where you would have where you would basically say this object the registry doesn't understand this, but this object actually references these 5 other blobs in some sense, would be interesting. I don't know how much of a pain that would be for the distribution side of things. But I'm rambling a bit. The point I was going to make is that I think aside from that, I think we're actually fine for extensibility. I don't think anything. I think the existence of MIME types and the fact that we have annotations and these other things, even though annotations are like per blob annotations are something that is actually not really widely supported by image tools. That's a different topic. But in theory, most of this is already handled, unless I'm missing something.
So just a point of order for time. To wrap up this one, and then I want to come to like a time scheduling kind of thing. What I think, because the one use case that was used was signing, and I'm hoping we're making good progress with the Notary 2 stuff, it'd be really interesting if we could understand a couple of other use cases so we could kind of wrap our head around the kind of extensibility that we're thinking here. And sometimes, because we all come at it with different perspectives, and it'd be really good to get like, hey, these are the kind of things we'd like to do with extensibility. I think it's more obvious on the registry side, although I don't know if we've actually ever written down all the different extensibility points we'd like to do, but it'd be interesting to think about the image spec side. What is the extensibility point? So in my personal opinion, I think annotations are interesting search metadata. But that itself is probably a whole long conversation. So I should probably just yank that back and not tease open the next one. So for the 3 minutes we have left, because those of us in the States, depending on where we are, it's late or really late. And in Asia, it's early. We should finish. My question that Amy and I were discussing, and Phil, actually, all 3 of us were discussing, was what time should we use? Because there's a combination of Asia, Europe, and India, as well as States. I guess I'll ask the people on this call because they attended. Is this like a reasonable time for you if we schedule this for next week so we can finish up the last 3 items? Does this work for everybody that's on the call?
I thought it was interesting. I have not been able to make 5 p.m. Eastern for a while, and I just happened to see on my calendar that 9 o'clock this worked okay, 9 p.m.
So for you are you on East Coast or are you on?
Yeah, me and Phil are both on the Eastern.
Okay, so for you personally, this is good. Phil, I forget where you are.
He's on Eastern.
Okay.
Yeah, I'm the same as Vincent.
And Josh, you're Central, or like for the people, this is late.
Kira Kolishikin, where are you at? Europe, right? It's like 4 a.m. for you.
No,
he's in the States, isn't he?
He's
no, Kira lives in Seattle.
Seattle? Oh, then
Seattle.
That's great. Oh, good.
Yeah, it's just dinner time for us, which is why I'm prepping with wine and starting to grill.
And I'm not drinking any. I'm drinking tea and water.
I'm representing you here. I don't know if you were here early when I said this. So, cheers. So, anyway, more serious. So we can schedule this time for next week. The other conversation we had was 7 a.m. Pacific time. The challenge there was lots of people that are working multi-continent had their 7 a.m.s booked for other cross-continent meetings. For those that do these calls regularly across continent, is 7 a.m. Pacific time, however that translates to where you are. Is that better or is this better?
We'll go with this one's better.
Okay. Obviously, Josh can say as he did this time. So we'll put out a. So why don't we do this for the sake of next week? Because it sounds like, at least from what I did a quick scan. Does anybody know where Nisha is? What time zone?
I think she's in Texas Central.
Okay.
Maybe not Texas, but Central.
Somewhere it states and somewhere reasonably in this range. Let's schedule next week's for the same time, and I'll talk to Amy about getting a doodle out or something. And because the people that don't like this time probably didn't attend, and we'll talk about doing a 7 a.m. Pacific versus the other time. 7 a.m. is midnight for you, Alexa. Okay. Thank you. All right.
But I mean, I'd be willing to take the sacrifice. If we do a rotating schedule, I'd be happy to take the sacrifice of once every 2 weeks.
We've done that. It gets complicated.
Once every 2 weeks.
People forget. Let's just stick to this one for a while.
All right. So let's do this. We'll do the same time. We'll do the same time bat channel next week. And at least we'll get through the rest of the OCI V2 stuff. And I'd like to, even though there's only 3 items left, I really like this one because we had a chance to talk more in depth around some of those. Last week, I felt like we did a good skim, but we didn't really get a good conversation around some of them, which I think is the point, because otherwise we can all read. So thank you for coming. Thank you for the APAC folks for joining, and patience for us getting to this time. And,
can we also have a Slack channel so that we can facilitate communication across different time zones, including Europe? And maybe we should rather focus on asynchronous communication like Slack and email so that we can collaborate across different time zones.
Are you saying a different Slack besides the OCI general?
Can we have some channel in the open container Slack? Maybe just like OCI Bridge channel.
I mean, we're making bridge.
Was the question that Slack isn't good? Because we know we have certain people like Alexa over there in the corner. Just gonna tease you, sorry. That aren't, and Vincent too, aren't big on Slack, but they've reluctantly agreed? Or is that is it you don't want Slack, or you want a special channel in Slack?
Just create a channel in the existing Slack.
Okay. We haven't had that much traffic. Do we mind just putting it in general? Because I've also found that having too many Slack channels gets just as confusing.
Yeah, that's what I was asking. Some people, due to, not that it's impossible to set up the bridges again, but since we do already have like matrix and IRC bridges set up on the general channel in the OCI, I think it's general. I have to.
Yeah, it's general. Yeah, I renamed all the channels recently to fix this, but yeah.
But if you don't mind, Akihiro, we could just use the general channel, and because it's been low enough traffic that I don't think it'll be offensive. Like it'll be fine.
Too noisy.
Mm-hmm.
I mean, I forgot about that. I was going to say really important. But the other thing is, like this group, like other than CNCF, where you have lots of people focused on lots of different things, we generally have a small, tight-knit group of people that work on this stuff. So I found, at least in my experience in the last 2 years, I guess, that the single, like we tend to have a single set of focus that we all kind of traverse on. So especially because the Slack stuff to interconnect with other external things is difficult. If we can just use a general channel, I think will be better.
Yeah. What I was going to say regarding async communication in general, my plan was that the purpose of these meetings is just make sure everyone's on the same page so that we're not talking past each other. And then when it comes to detailed proposals, I wouldn't expect us to have tons of meetings like this. It would be, ideally, we'd have most discussion async, and then the weekly meeting would just be a way for us to recap and bring people up to speed. I wouldn't want us to have hour-long conversations every week to do the spec discussion, especially since I imagine once we have a rough idea of the proposals and we have a couple of prototypes, so we have an idea of what this would look like. I imagine it's not something which would require us sitting in a room together for like 4 hours to discuss. I think it's something which we can do asynchronously. But I mean, if we started discussing this asynchronously, it would have gotten off topic very, very quickly. This is the nice thing with sync meetings, is that at least there is an agenda that you can follow, rather than having mail threads that are like 500 emails long.
Email is definitely, in my personal opinion, email is a channel. challenge because it just goes off in all directions.
Yeah.
Okay, so just for the sake of everybody's time management, we'll wrap up. We have the recordings. I'll thank you to Amy, who will listen maybe later, and Phil, who are getting all the postings done. And we'll do, for next week, we'll do the same time, exact same time for everybody, so whatever that is. And we'll discuss next week what we want to do after that. So thank you, folks. Have a great day.
Thanks, everybody.
Later.
Happy hacking.